So let's kick off our session. So now we are going to, before we can go further in discussing about functional interfaces, you can even review to yourselves from the documents I sent you to make the work easier and for us to go faster. Let's just have a very small recap on interfaces, right? Because the first thing that we talk about on Lambda expressions are the functional interfaces, right? So let's have a short recap on interfaces. So let me create a package, and in this package is where I'm going to be doing activities related to interfaces. And here I'm creating, in the documentation, we have a vehicle class, a vehicle interface. Are we together? So in the vehicle interface, this is how an interface actually looks like, right? And in the documentation, you have an interface is a contract, right? Of how a class is going to, of what a class should implement, right? Or implement or do. So one of the things that an interface can have is like, let me say constants. So for example, if we are looking at the class interface, let's say the maximum speed is this one, right? And then we also have abstract methods. Do you remember what abstract classes and methods are? Or especially abstract methods. What are abstract methods? Anyone? Yes? Methods with no body, right? Okay. So let's create an abstract method to start a car, right? And let's create another one to stop a car. And then we also have seen that we can create a default method, right? And our default method is going to be a method to honk. I guess you know what to honk means, right? Do you know what to honk means? To honk. Yeah. I guess you know what to honk means, right? Yeah. Okay. Great. So maybe our system is going to say beep beep, right? And we can also have a static method. And do you remember what static methods are? Anyone with an idea of what a static method is in Java? Static method, anyone? Why do we create, if for example, I'm in the main class, why do I say public, let's say public static? Let's say void say hello. Let's say I'm creating a method. I say hello, right? But if I create a model, let's say car, for instance, it's a method. It's a method that, yes. Exactly. So a static method is a method that that belongs to that class, and you don't need a method to call it, right? I mean, you don't need an object to instantiate an object to call it, right? So let's now create a static method. So this method is going to be telling us if something, whatever we have is a vehicle or not. Okay, so this is an example of an interface, right? So now let's try to implement this interface. Let's have our car class. And let's implement the vehicle interface. And the reason why we have these rates, I guess you know why. Why do we have these rates? We didn't override. Override what? Yes, we have not yet overridden the methods in vehicle interface, but which functions or methods are we supposed to override here? Which one? Abstract methods, right? These two. Okay. So let's say question. Yes. Uh-huh.
As part of the customers when we use it. But I thought that in an interface to contain only methods without implementation.
Not necessarily. An interface, remember, it's a contract. It tells you what you should do. But this is not just a class you can use anyhow you want, right? So here you say, I want you to implement these functions. It's like what you expected, right? But you can also add default functions, right? You can either override it or not.
Yes.
Yes. In an interface, you can override it or just leave it as it is, right? Okay, okay, let me see. Yeah, let me check. If it is default, then it should not be static. Because the reason why this one is static, we want it to use it here only. It is going to belong to the vehicle class. So as you are going to be implementing it, that's when you're going to understand it better. Right? Okay. So let's implement them and see how we're going to be using all these methods that we've defined here. And then you're going to understand, you're going to see that there is a difference between the way you're going to call a vehicle and the way you're going to call honk or any other methods, right? So let me come back here. Let's try to be as fast as we can. Public void start and say maybe the car is running and we override public's void stop and class car is stopped, right? And here we are fine because the most important files that we're supposed to implement are these abstract ones, right? And now here you only have options. If you want to override this one, fine, you can override it, or you can leave it as it is, right? This is the first thing. And second of all, this one belongs to the vehicle class, right? So you don't have to touch it. It belongs to this class, right? Okay, now that we have a car object, let's go to the main file and try to play around with this car object. So let's call our interface. So we instantiated a car, right? And it is going to be of type vehicle. It has to implement everything we have in the car, right? Great. Now what you are going to do, for example, course, you obviously know that we can start the car, we can stop the car, and because our vehicle class has this default honk method, we can also use it as well. And if you were to run it, this is what you would get. So I guess you can see that they say car is running, car is stopped, and beep beep, right? So this is an implementation of an interface, right? And before we can conclude with this, you can, for example, we are now going to see how we can use those static methods that are provided by classes, right? So for example, we want to know the maximum speed of the car, right? So I would write, let me put it in a system output and say max speed is maybe something like this and plus vehicle dot max speed, right? And where does this max speed come from? It is the constant we provided here, right? So you treat this as a constant. In the documentation you have, they say it is implicitly static, public, and final. First of all, you can't change anything about it. This is the same as if you would write public, static, final, right? So the reason why we didn't write it here is simply because it doesn't really matter, right? If you write it like that, it means, and remember, in Java, constants, we write them with capital letters, right? So if you define it like this, it means that first of all, it is publicly accessible whenever you have a vehicle, right? It is static, which means it belongs to this class, right? And then final means the final value you have here cannot change, right? So writing this or not writing it is literally the same, right? So this is why you even saw that it was not put in a similar color. And something else that we can try here is verifying if our class is, if our car is a vehicle or not. Vehicle, so we say vehicle dot is vehicle. This is another demonstration of a static method. When you're using static methods in Java, if you have a static method, you can call it immediate, right? Without having to come in and use my car dot is vehicle, right? So you start it, you can call it immediately because this method belongs to the vehicle class, not to, in fact, the vehicle is not even a class, it's just an interface, right? So if you define something as static, it only belongs to that method. Who can give me an example of where you've seen another example of static methods in Java? Another example of static methods that are publicly known. Here is another example of a class. Whenever you're going to be doing mathematical related activities in Java, right? You're going to be using math class, math.random, math.absolute value. Yes, math dot square root, and so on, right? So why do we just suddenly write math dot, right? And we know that math is a class, right? It's a class provided by Java, right? So we call it and use it immediately without having to instantiate an object. The way we were familiar with calling functions in Java is like this way. For example, we're just used to having, let's say, a class called car, and then in that class you have a method called start, a method called stop, and you have to first instantiate that class, that object, and then call the method using that object. But when you have a static method, you can directly call the method you want without having to create a new object. This is why, since we had in vehicle, a static method called is vehicle, we simply wrote vehicle dot, then dot is vehicle, and we immediately used it. The same thing with math in Java. All these math.random, math.square root, math.absolute value, they are all static methods, right? So now I guess you have a deeper understanding what we say when we mean when we say static methods, interfaces, and abstract methods, right? Now we are on the same page. Great. So from your documentation, you also have key features on interfaces, right? Some, of course, interfaces have different use cases, right? And you can use interfaces. For example, I guess you can see that here we implemented one interface, right? It is possible that you can implement more than one interface, right? If, for example, we had another interface called maybe, let's say, truck, let's say, right? So we'd add here another interface to implement, right? So the third part that we are more interested in today is this one. Let me find a place to put it. Okay, let me simplify. Let me close these ones. And now come back here to interfaces. So I'm going to create an interface and call it calculator. Public interface, sorry. And what you have already seen is that we have this annotation called functional interface on top of our calculator interface or whatever interface. For example, you have the one called, you might have seen one called greeting, right? And this interface has only one method that it is implementing, right? So let me just maybe write calculate, and it is going to calculate, it is going to implement only, we're going to implement only this one method. So this is what our focus is on for today, right? So let's now go in the deep on what these functional interfaces are. So as we said, Lambda expressions are here to simplify the way we use methods, right? The first thing that we've seen that is that when you're trying to use methods, most of the times you need to create an object, right? And then you use that, or you call that method after instantiating that method, which is sometimes a lot of code, right? And if you were to use this, let's say, let's have another different interface, the one that most of us have been using, called greeter. You're going to see how much code you are going to write. And then you are going to simplify that code using Lambda expressions. So you have something like void greet and then function interface. And let's provide a name that someone is going to be providing to greet people. So this is our interface. And in functional interfaces, when you're using this annotation, we are having an interface with only one method to implement, right? And so now let's go in our main function. Allow me to create another main class, sorry, to use when you're learning. Let me say lambda and interfaces. So this is our main class. Let me minimize this and let's have our main function. And we are going to use the interface we just created. A question? We're just going to use the interface we have, right? And implement the other greeting. Is it greeting method? Greet method, right? So this is how we should use it. Before the coming of Lambda expressions, this is the hassle people would have to go through. They would write greeter, right? They simply call the interface as you've seen it when we were dealing with the vehicle, right? We first called the vehicle, then gave it a name. And let's say hello greeter. We defined it like this, right? And then inside, this is where we are now going to override. Then we provide now let me call it the correct implementation of the implementation we want to do for our greeting or our greet method, right? And this is not done because until now we can't do anything with this, right? So then we're going to say hello greeter then dot greet. Then let's provide the name. We want to be Chanel. Is this how we write Chanel? Like this? WLE, right? Okay. Yeah. So here you have all this entire thing, right? And then you have to also write this so that you can display the name here, right? So this is, of course, the output you should get. Hello, Chanel, right? So as you can see, this is kind of fun, right? But this is too much, right? Now, how can we simplify this? Of course, this is when Lambda expressions come in, right? Let me create a new class. Let me create a new class to simplify things. I feel like this one should not be called Lambda expressions. Let me change it and call it before Lambda. Okay. Now let me call this one with Lambda. I guess when you're going to be looking at on GitHub, it is going to be easy to read and find it, right? Okay. So now using Lambda expressions, of course, we still have our greater interface defined here, right? But now using Lambda expressions, all we are going to do is, of course, we define our interface here and provide the name. And then instead of going through the entire process, we are going to use Lambda expressions. But before we go there, I want to highlight two things. How do Lambda expressions look in Java? Lambda expressions have two parts, right? put these things in a comment. So with lambda expressions, we have two parts. One part is going to hold the parameter, and another one is going to hold the expression, right? So this is like a formula. And here, if you have the parameter, this is how to look like. And here you would put the code you want to execute. Literally, this is like a function, right? I guess you remember the way functions used to look like. You would write, like, this is a function, right? A function has a place you can put parameters and then the body of that parameter. So just imagine now if you can simplify it to something that looks like this. You can still here add more than one parameters. You can create a lambda expression without parameters, right? As long as you obey the structure, right? And then another question is when or why do we need lambda expressions, right? Of course, despite the fact that lambda expressions help us to simplify things, but there are places when we might need to have a function. You know, you want to use methods without defining them here and there. You just want to do something, then you provide a function and you move on. And the place you might have seen it is when we are using the for each loop. Is it for each? I hope I'm not confusing JavaScript and Java. But the reduce function, reduce, you might have used them, right? That is one example. Reduce, yes, we have reduce in Java. But for each, I'm not sure. We also have it, right? Okay, great. So now we are going to going to use these lambda expressions to add them here. Instead of having something that looks ugly like this, right? We're just going to simplify it into a very small and, let me say, beautiful implementation. Sorry. Here we are going to write. I'm just going to provide the name that we want to receive, and then arrow, and then we immediately provide the message we want to provide. Hello name, hello plus name, right? So if you can see what you have here, it's similar to what you have here, but what you have cut is all these entire things here, right? It's directly go to our system out.println, and this part here, we just provided it with an arrow. So in fact, we didn't really need to come here back and write override public void greet and stuff like that, right? So immediately did something like this. And you can even have different implementation of this interface, right? Let's say here, if I wanted to, let's say this one is going to be calling people. Let me say people, right? And then I want to create another implementation of that interface, which is going to call AI tools. AI. Then I would have to go back and rewrite everything as it is. And then here I'm going to provide the name of the AI, right? So here I would come down here and say maybe AI greeter dot greet. Let's say hello Gemini, right? Just imagine if you want to implement this function 10 times, how long your code is going to look like, right? Messy. But with Lambda, I just come here and write greeter, AI greeter. And here we are done, right? If you want to call it, of course, calling it is going to look similar to what we have here, right? but at least you would have changed a very big chunk of the code, right? So I believe now you see the difference. Do you? Right? So this is the first thing. So now, using Lambda expressions, there are some built-in functions that you might be interested in using, right? And those functions have different use cases. Some may be used to test, some may be used to return outputs of things or transform information. Some may be used to just do some activities without having any parameters, and some may be just there to provide data, right? So we are going to go through a few of them and look at how they would look like. The first one is a function called predicate, right? So allow me to create a different file for this. Make sure things are clear. Let me call built-in predicate. So you understand that this one is going to be about predicate. And here we are going to have our main method. And before we can even go far, from the documentation I sent you on Slack, this predicate is used for testing. We can use it to test, right? And it's going to test a condition. If a condition is filled, and then it's going to return a Boolean, either true or false, right? So when you are testing, you need to first create a setup. Let me call it like that, right? A setup is like the data you want to use to test, right? And then try to now imitate the test, and then you check if the test is going to work, right? So I hope people, tomorrow you have presentations. Do you? Presentations are on which day? 4th or 5th? Someone here said Thursday. Okay, whatever, fine. Those of you who are working on testing, I believe you're going to tell us the 3 steps when you're testing, right? There are 3 steps you need to, unless you don't have testing in the topics you are working on. Yes. So there are 3 steps when you are testing. Let's say you have a function to test. There are 3 steps in which you can separate the logic, right? One is probably called preparation. Is it preparation? When you are testing, you are writing test codes. Yeah, you use in the framework you use, but okay, you are going to look at that. So we are going to imitate those steps here. First, let's create a list of strings, and we are going to put some fruits. Let me first import the array list, the list class, and immediately I'm going to get some fruits here as an array. I'm going to have apple, banana, cherry. What else? 8. Yes, watermelon. Watermelon. Welcome. Okay. Sure. Then we are going to have raspberry. Wait, do you know what raspberry, a fruit called raspberry? Oh, we are all Africans. But you should find it at least. It should be somewhere in Rwanda. Or you can even Google it and see how it looks like. Give me a second. I want to Google it and see. Probably there are things, they look like things we call inhale. Yeah, but they call them inhale as well. Right? Yeah, they are called inhale as well. They are not the same, but in Rwanda we call them the same name, right? So if you find them in a supermarket somewhere, please bring some to us, right? I don't think you can find them in local markets. Okay, let's continue. For me, the first thing I realized that I didn't know that there is a P in raspberry. Okay, so now let's use predicate. We're going to, as a lambda method, we're going to use predicate to check if fruit is red, right? So we're literally going to make a setup, predicate, and I immediately called it here. It's provided by function class, and the right is of course going to be having strings is red. So I'm going to paint these fruits, literally. I'm going to paint these fruits, and for each fruit here, I'm going to now use lambda expressions. For each fruit, I'm going to say equals apple. So this is red. I'm just going to, now this is like a function I defined, right? It is going to be having a fruit, then we paint that fruit, right? And another one that is going to be red. You just tell me the fruits you want to be red. Watermelon, okay. Let me hope that's how we write it. Watermelon, by the way. Fruit dot raspberry. This is fine, right? And then let's see how we could now check on the fruits that are red, right? If you would write it like this would give you an error, right? If you just want to test to see if an apple is red, right? Therefore, you need to first look through the entire list, right? And check on each fruit. If the fruit is red, you're going to return that fruit, the name of that fruit, right? But to check, if they reach to a fruit that is red, you're going to return a value equals to true, right? So we're going to have, let me just, as it is in the documentation, have a small message here saying red fruits. And then here below, I provide a for loop for each fruit, which is a string. I'm going to check, is that fruit red, right? If it is red, then we display it. So I guess you can now see that we are saying is red, right? Dot test. Then we provide the fruit. So this is how predicate is used. You use predicate when you're trying to test things, right? So this is one implementation of lambda expressions. So these are like built-in functions that you can use in lambda expressions. And this one specifically is used if you want to test things. So you first make, you have the data you want to use as your test subject. You make a setup, like we are going to paint these fruits, right? So we go through each fruit and we paint it red. So say, okay, that the red fruit is going to be apple, and another one is going to be watermelon. And then we go here and run through it and check on each fruit. If we find out the fruit is red, yeah, we display it. If it is not, we don't display it. So if we would run it, this is what we would get. So we will get apple, watermelon, and raspberry, right? So this is one implementation. There are so many other implementations. I'm trying to look for an implementation which is a little bit fun. Okay, here I can see there is a function called consumer, right? Which receives a parameter and then it does something, right? So let's try to implement it here. You're in consumer. Let me try to be as fast as possible. Let me hope you are not hungry now. Fine. Because the usual time I was supposed to be the one to tell you to go for lunch, which means that around this time you are not hungry, right? Okay, yeah, I'm going to be as fast as I can. So again, let's make a small setup. Again, you're going to have a list of guests. And I guess today you are now familiar with the way we are writing arrays as lists, right? We just define a list which looks like an array, but here we transform it into a list. Let's say we have these names, right? Okay, so what we simply want is to use this consumer to print invitations for the people in this list. And this is a very interesting example because we are going to see how we can use lambda expressions, right? Without having to go aside and define methods. In fact, the way it would look like otherwise would be even more complicated. Let me first complicate it and then simplify it for you to understand the way it would look like, right? So let's say I want a function. I want to simply be calling every guest, right? And give them the invitation, like say, dear Alice, you are invited to my wedding, as an example, right? The normal way you would do that is to come here and define a public static, let me call it invite, public static void invite method, right? And write, and it is going to receive a parameter. The parameter is going to be, let's say, name. And then we provide the message. Allow me to copy the message. And here we are, right? Let me just call it guest here as well. So this is what we are supposed to do in the usual way. If you want to create a function, which is going to be, we are going to be looping through all these guests, and then we invite them, right? So we would come here, and of course, we are going to use a for loop for every guest. I'm going to give them invite and then provide guest like this, right? And let's run and see what we would get. I guess you can see the output you have. This is correct. This is fine, right? But what if we would do it even easier, right? So what is the easiest way to do it? Is to write it in a single line of code, right? Of course, I don't know if you do it like this, it will work. Yeah, this is literally a single line of code, right? But it is still too much, right? Yeah, there are literally 4 lines of code, but this is still complicated, right? So let's simplify it using lambda expressions. So you would call the consumer, right? Consumer, and provide the data it is going to be using, call invite. Allow me to, let me call it invite to avoid confusions, right? And let me comment, okay, I'm just leaving it like this and complete my implementation. So we are now going to take, I think where we saw lambda, where is it? You've seen that our functions are going to be having 2 parts. This is going to be where I provide the parameter and then the expression, right? This is literally a function. These ones, they are called anonymous functions. They don't have a name, a known name, right? So it's just a function, but we don't know the name of that function. So you're going to pass this anonymous function here. But one thing we know, it is going to have a parameter, and that parameter is going to be the guest, right? And then we say, we literally provide the message we have here, down here. And we are done. Invite dot, so we go through the string and then accept, right? So here I will just use accept for it to accept the information that you're going to provide as a parameter, right? So this is why this one is called a consumer function, right? So it is going to consume information, then it gives us whatever we want it to do, right? So the main difference between using this one, you just call the function as it is, then you provide a parameter. But when you're using consumer, you need to remember to add dot accept. Then you provide the parameter. But for you just to analyze between this implementation and this one here, which one is simpler? Yeah, of course, both are simpler, but be honest. This one, right? Of course, this one is still new in your brains, right? You're still trying to understand what happened, but this one is way simpler, right? And this is how lambda expressions are going to be using them. And even tomorrow, I want even to see simpler ways to use this system out.println and maybe display things inside there. Instead of using an entire for loop, just to loop through things, right? Using a system out.println, right? So this is literally what we are talking about when we say lambda expressions. Of course, there is another long list of other things you need to, and other built-in methods you need to look at in the documentation. And yeah, try to have a look on them, try to play around with them, and then make sure you also review on what we have in tomorrow's session, right? Great. So any question before we can close our session? I know the reason why there is no question, right? Probably questions are going to arise tomorrow. I'm sure of that. No, not 2 more weeks. You don't have 2 weeks. So this is what we would get similar. The output is similar to what we had here. Okay, great. So thank you for your attention.